Hey guys, Mrs. Dan's here. So today we're on lesson 11 and we will be looking at some compound figures. And with compound figures, sometimes we add volumes together because the figures look like they're stuck together or there's multiple figures um, within one problem. Other times we actually have to subtract, and that subtraction is because there's kind of like maybe a hole going through the shape. So we find the volume of the shape and then subtract away however much volume that hole takes up. You will need your calculators. I know it says check homework answers from the display. If we were in school, that's what we would do. But you guys are going to go back and look at the posted answers. And you should be working on the do now, which is page 53. But of course, I'm going to go over the do now with you. During this video, we're going to be doing some of the classwork questions together. There's only a total of 8 questions in this lesson. So I will do some of them with you and the rest you need to finish. You will finish this entire lesson when the video is over. And again, you'll be able to find those answers posted somewhere. We already should know the answers to these questions. I had them posted last video. Volume is really the filling of a three-dimensional figure. And remember, to give an exact answer means we didn't round it. Usually when they say give an exact answer, that's kind of like a hint that we probably used pi in our formula because pi is irrational. So I can't give a decimal form of that answer and call it exact. So when I ask for an exact answer, most likely we'll keep pi in our answer. And that's what this third question is. What does it mean to leave in terms of pi? Remember, it really means that we'll see that pi symbol in our answer. And the shapes that we see pi in are anything that are circular. And to round, of course, means like to round to the nearest tenth, hundredth, thousandth, wherever it asked you to. Typically, if like wherever we're rounding to, if the number after it is greater than 5, we round up. Volume of a rectangular prism. On the formula sheet, it says V equals capital BH. We talked about capital B as being the area of the base. Therefore, when we're trying to find the volume of a rectangular prism, we do length times width times height. That length times width is the area of the base. Volume of a cylinder, it's given to us on the formula sheet. Volume of a sphere, it's given to us on the formula sheet. And volume of a cone is given to us on the formula sheet. So remember, you could always turn back to this page. And general prisms is that capital B times H, and we change that capital B to the area of the base. So with a rectangular prism, it's a length times width, and then times it by the height. But we have the cylinder formula exactly given to us, and the sphere formula and the cone formula. It's all given to us on this sheet, so make sure you always refer back to it. And like I said, your homework is to finish the entire lesson. So let's get going. The do now, approximately how much air would be needed to fill a dozen soccer balls? So you need to know, first of all, that a dozen is 12, so there'll be 12 soccer balls. Soccer ball is definitely in the form of a sphere. So I know I want to use that formula that says 4/3 pi times the radius cubed. And it's telling us that the radius of one of the soccer balls is 14 centimeters. So I know in place of the R, I'm going to use a 14. So when I use this formula, really I'm finding the volume of one soccer ball. Finally, we have to notice that it does ask us to round our answer to the nearest hundredth. I always do my exact answer first and then change it to a rounded answer. On your test, sometimes it'll ask for the exact answer, other times a rounded answer. So make sure you know how to do this. Remember, I like putting a 1 underneath here. So on my calculator for my numerator, I'm going to do 4 times 14 times 14 times 14. So here's my calculator. 4 times 14 times 14 times 14 turns out to be that. Remember, I didn't hit the pi button, so I still have pi in my answer. and it's 10,976 pi all over 3 times 1 times 1, which is all over 3. If I do that 10,976 divided by 3, this is my answer in terms of pi, 3,658.6 repeating. Pi. Centimeters cubed. That's an exact answer. They wanted a rounded answer, so I will take this number on my calculator and multiply it by pi. As soon as you hit multiply by pi, you know you're getting a rounded answer. So it's 11,494. It says round to the nearest hundredth. So it would be 0.04. 11,494.04. Centimeters cubed. This is my rounded answer. I like to put a squiggly equal sign to remind myself that it was rounded. Oh, that I shouldn't have boxed it in. That's not my final answer. This is just one soccer ball. One soccer ball is about that. There's 12 soccer balls. So now I'm going to multiply this answer by 12. I'm actually just going to use this answer that was on my calculator and now hit multiply by 12. There's my final answer. When I round it, I get 0.48. This is my final answer. This was for one soccer ball. Now, being able to do this do now really means that you can do question number 1 here in the development. So a box contains 9 identical glass spheres. So again, volume of a sphere. And the spheres are packed tightly packed, as shown below. So being tightly packed is important because notice all the way across here it's 12, and there's 3 of them going across. And if it's tightly packed, that would mean that each of these diameters has to be 4 inches, because 4 inches plus 4 inches plus 4 inches is 12 inches. So that's the importance of being tightly packed. There's a question like this on the test. At least there was one on last year's test. So I think it'll be similar this year. Now notice I drew this line going all the way across the sphere, which means that the diameter of one sphere is 4 inches. Therefore, the radius of one sphere is 2 inches. So when I use this formula, I definitely want to plug a 2 in place of the radius. Now this would be for one sphere. Once I get my answer, I'm then going to multiply it by 9 to get all 9 spheres, and it says round your answer to the nearest tenth. So I'm going to have you finish that, and then you can check your answers after I post it. But it's just like the first one that we did, and I started you off pretty well. Next page, you can see on number 2 that these are shapes that are stuck together. So on 2A, it's 2 cones stuck together. On 2B, it's a cone and a cylinder stuck together. So just a little note, whenever you have figures stuck together, we really want to find the volume of each figure and add it. So I'm going to do B with you. You can do A on your own when the video is over. This will help us practice to find the volume of a cone and the volume of a cylinder. So I want to do the volume of the cone plus the volume of the cylinder. That's how I'll get my final answer. The total volume would equal the volume of the cone plus the volume of the cylinder. So volume of a cone, when you look at your reference sheet, it's 1/3 pi r squared h. And the volume of a cylinder on your reference sheet is pi r squared h. Be really careful with whatever numbers we need to use. So for the cone, this 3, since the dotted line ends halfway through, it must represent the radius. And the height of the cone is this 4. And I'm going to work myself through this before I even do this cylinder. So remember, I think about these as being over 1. My numerator, remember, I'm going to always do my answer in terms of pi to begin with. So my numerator is 1 times 3 times 3 times 4. That answer gets divided by the 3 times 1 times 1 times 1, which really means it just gets divided by 3. So this is a 12 pi. Remember, pi is my answer because I didn't push the pi button. For the cylinder, if I substitute in my numbers correctly, the radius of the cylinder happens to be the same thing as the radius of the cone. The height of the cylinder is different. The height is this 8.5. And there isn't any fractions to worry about here. I want to do 3 times 3 times 8.5. So my answer is 76.5 pi. Now pi here is kind of like a variable. I can only add these things if I have like terms. So I do have like terms. They're both in terms of pi. So I'm allowed to add the 12 pi to the 76.5 pi to get 88.5 pi. This is an exact answer. I'm just going to put my units. It's centimeters cubed. If they wanted a rounded answer, they don't. See, it says in terms of pi. But if they did, I would take this 88.5 and multiply it by the pi. And that would be a rounded answer. If I rounded to the tenths, it would be 278.0. But again, they just wanted an exact answer, so I'm done with this question. Next, I just want to look at with you number 3. These are 3 figures stuck together, so find the volume of each and add it. Number 4 I want to do with you. So it's asking us to find the volume. It's not labeled on the picture, but in words it tells us that the diameter is 6 inches. Diameter. So this is a cylinder down here that, like, you're not seeing the whole thing because it's a solid sheet. So the diameter going all the way across is 6 inches. This top piece is half of a sphere. Half a sphere we call a hemisphere, but it's sharing that same diameter. And the height of the cylinder is 2.5 inches. So to do this one, I would find the total volume would be the volume of the half of a sphere plus the volume of the cylinder. So volume of a whole sphere is 4/3 pi r cubed, but since it's supposed to be half, after I get this answer, I'm going to divide it by 2. Then I'll add on the volume of the cylinder, which is pi r squared h. Notice it asks us to round to the nearest tenth. So let's substitute in our numbers. If the diameter is 6, then the radius is 3. Radius is always half of the diameter. Whatever this answer is, remember I have to divide by 2 because it's only half of a sphere. So 4 times 3 times 3 times 3, that's my numerator. Then I divide that answer by the denominator. 3 times 1 times 1 is just 3. So this turns out to be 36 pi, but don't forget, I only want half of it. Half of 36 is 18 pi. They do want it rounded to the nearest tenth. I'm going to do that at the end, though. I'm just going to leave it as an 18 pi for now. My cylinder, pi times 3 squared times 2.5. So I'll do 3 times 3 times 2.5, 22.5 pi. Since these are both in terms of pi, I can add them. 18 plus 22.5. So 40.5 pi is an exact answer. They want it rounded. So 40.5 times pi is that, rounded to the nearest tenth, 127 and 2/10, 127.2 inches cubed. So there is a question about half of a sphere on your test, so make sure you just remember that you find the volume of the whole sphere and divide by 2. Next page. These now are different. So this is like a picture of an actual bead, like that you can make jewelry out of. You would put the string through that hole there. But really what this bead is a rectangular prism with a cylindrical hole. When you drill a hole through it, it's like the shape of a cylinder. So this is like a drawn picture of it so that maybe you can see it a little bit better. Since that's a hole, that cylinder is inside of that rectangular prism. So this is a case where we subtract them. It's not two shapes stuck together. It's a shape inside of a shape, and that inside shape is taking up some of the space. So when it's a shape inside of a shape, when you're trying to find like maybe the volume of something after a hole's been drilled through it, or sometimes it's like empty space, this is a case where we subtract the volume. So a little note, usually when it's a shape inside of a shape, we subtract the volumes. So I'm going to do this number with you. I have to label my picture. So let's read. So Nate uses a cube shaped bead with side lengths measuring 6 millimeters. So this is 6 millimeters. Since it's a cube, all the sides are the same. Each bead has a circular hole in the middle. The diameter of the circular hole, diameter is all the way across. The diameter is 2 millimeters, which means that the radius would be 1 millimeter. and they want the volume of the bead. And I had already told you we'll be subtracting these volumes. So we're going to do the larger or the outside shape, so the cube, the volume of the cube, minus the volume of the cylinder. So volume of a cube is length times width times height. Volume of a cylinder, pi r squared h. Does say round to the nearest tenth. I'm going to talk about an exact answer first, though, like what I've been doing. So this isn't so bad. 6 times 6 times 6. Again, if you're allowed to use your calculator, if you don't know what 6 times 6 times 6 is, just pull out that calculator. It's 216 millimeters cubed. And we're subtracting pi times the radius we said was 1, because it's half the diameter, squared, times the height. Now do you see that the cylinder goes from the top of the cube to the bottom of the cube? Therefore the height is the same as a cube. It's 6. 1 times 1 times 6 is just 6. So an exact answer for this cylinder is 6 pi. If I wanted an exact answer for this total volume, I would say this is it. I can't subtract this 216 and this 6 pi. They're not like terms. So the total volume as an exact answer is just 216 minus 6 pi. They do want me to round it, so I can use my calculator. And I can actually type this all in my calculator. I could do 216 minus 6 pi. Right? I could type it in just like that. And that's my rounded answer. They wanted to the nearest tenth, so 197.2. millimeters cubed. And this is an exact, a rounded answer. So I subtracted these volumes because it was a shape inside of a shape. There was a hole going through the cube. With holes in the ground, you take away the dirt. So that's like subtraction here. Number 6 is also a subtraction problem. It's not like we have a hole going through it. Let's draw this picture. It says that 3 tennis balls are packed inside of a box. So maybe the box looks something like this. And there are 1, 2, 3 tennis balls inside of it. The box is 12.1 centimeters long and 3.5 centimeters wide and 3.5 centimeters tall. And each ball is 3.3 centimeters in diameter. So all the way across, it's a 3.3. So if the diameter is 3.3, the radius is half of that. 3.3 divided by 2, 1.65. So it's asking what the volume of the empty space in the box. So I wish I had a different color. I don't. Oh, can I use a highlighter? Nope, no highlighters here. So this space around the tennis balls is what they're asking for. So empty space really is like a subtraction problem. If I find the volume of the box and subtract away the volume of the tennis balls, I'll be left with that empty space. So shape inside shape typically tends to be a subtraction problem. So the empty space really would be the volume of the box, which is a rectangular prism, minus the volume of 3 spheres. So I want to do 3 times each of the spheres. So the rectangular prism, length times width times height. $148.225. And I have to subtract away the volume of 3 spheres. One sphere is 4/3 pi r cubed. The radius we said was 1.65. So I'm going to do just one sphere first and then multiply it by that 3 on the outside. Notice these words here. 3 tennis balls are packaged in a box. The box is that long. Each ball is that wide. What's the volume? Doesn't tell us to round, doesn't tell us to keep an exact answer. So when it says, what is the volume? And we don't have any permission to round, we're not allowed to round. So I have to do this exact since it didn't give me permission to round. So 4 times 1.65 times 1.65 divided by 3. So one sphere is 5.9895 pi, but I have to multiply that by 3. 17.9685 pi. This doesn't have a pi in it. Remember, I can't subtract if they're not like terms. This would be my exact answer. If they ask me to round, then I can type in this into my calculator and get a rounded answer. But this is how I'm going to leave it since it didn't tell me I had permission to round. And then on the last page, I'm just going to do the last problem with you. This is empty space again, so you'll be subtracting on number 7. Number 8. Based on the following drawing, if the top funnel was filled with water and then emptied into the bottom cone, what fraction of the bottom cone would be filled with water? So it makes sense that they're asking what fraction would be filled. I can see that this top cone is smaller than the bottom cone. So if I filled this cone once and poured it in here, it would go up a certain height. Just estimating, like maybe it would go up to here. So they're asking what part of the cone is filled, what fraction of that bottom cone would be filled with water. So why don't we find the volume of this top cone so that I know how much water is going into the bottom. So volume of a cone is 1/3 pi r squared h. The radius is 3 and the height is 4. So my numerator is 1 times 3 times 3 times 4. I don't really need my calculator for this. 3 times 3 is 9. 9 times 4 is 36. Pi divided by 3 really is 12 pi. So the top cone has a volume of 12 pi inches cubed. So that 12 pi is going into the bottom. They're asking what fraction of the bottom cone is filled with water. So now let's find the volume of the bottom cone. Let's find out how much it really can hold. So the radius of the bottom cone, remember this 12 is a diameter. If the diameter is 12, the radius is 6. So 6 times 6 times 8 divided by 3, 96 pi. So the bottom cone can hold 96 pi. The top cone can hold 12 pi. So how do I write that as a fraction? It'll be like the larger volume over, no, I'm wrong. The smaller volume over the larger volume. What's so nice about this fraction is that there's a pi in the numerator and denominator. So those pi's simplify to be 1 over 1. Actually, even 12 over 96 simplifies to be 1 over 8, right? 12 goes into itself once, and 12 goes into 96 8 times. So the bottom cone would be 1/8 full of water. It does ask us to explain. This is a whole bunch of work. It's not an explanation. I'm not going to write out in words. I'll talk about it though. So if it asks us to explain, what you would say is that you found the volume of the top cone and the volume of the bottom cone, and you wrote that those volumes as a ratio, as 12 pi over 96 pi, which simplifies to be 1/8, which means that the bottom cone is 1/8 full of water. So you're going to do the few problems that I left for you. There's not many, right? You have to do number 2A, number 3, number 7, and I think you have to finish number 1. So come back, check your answers, send us any questions, and we'll talk to you soon. See ya. Bye.